Hey guys, in this video I want to show you how to make a procedural rocks in Houdini, and in the next video we can make a fluid simulation on these rocks, so let's dive in. So first let's add a new geometry node, and you can rename it rocks. You can dive inside. So first let's start by adding a sphere. So here we can select the node and you can press P to open the parameter of this node. So here in my case I will put the radius at 0.75 on the x-axis, but of course you can change the settings if you want. Here I will put the primitive type to polygons and I will increase the frequency to 50. So now I will add a normal node and I will put my normals on points. So you can visualize the normals by clicking on these icons. So now you can add a scatter node. So here in my case, I will put the total count to 7, but you can change this value at any time. Now I will add an attribute randomize and I will create a p-scale attribute, and in that case we can create a random value between the minimum and the maximum for the p-scale attribute. So here for the attribute name I will put my p-scale attribute, and here I will put the dimension to 1 because this is a float, and here I will put the minimum value to 0.3 and the maximum value to 1. So now I can add a copy to points node. I can plug those points to the last input, and then I can plug a sphere on the first input. So here for the settings of these spheres, I will put the radius on the y-axis to 0.75. And here I will put that to polygon and I will increase the frequency to 50. And I will decrease the uniform scale to something like 0.95. So now I can merge this first sphere with all those little spheres that we have created with the copy to points. So let's add a merge node, plug this one and this one to the merge. So at the moment we have this result, so we can convert those geometry to VDB. So in that case we can create one and single clean geometry. So let's add a VDB from polygons. And here with the VDB from polygons, we can decrease the voxel size value to get a bit more resolutions on the final geometry. So here we can put the value at something like 0.025. Now let's add a VDB smooth SDF. And here I will keep the settings by default, which is mean value and iteration at 4. So now I can convert that back to polygons. So let's use the convert VDB node. And here I will choose my preset to polygons. So now we can apply some noise on this geometry, but first let's start to convert this geometry to VDB density. So let's use the VDB from polygon one more time, but this time we don't want to convert this geometry to SDF VDB, we want to convert it to fog. So here we can disable these options and you can enable the density. So here I will put the voxel size to 0.01. So let's add the first volume warp. And here we can dive inside. So we can add some noise on our density. So let's add an add node. We can plug the position to the first input of the add. And here we can use a curl noise, and you can plug the position to the position input of the noise, and we can plug the noise to the second input of the add. And then we can plug the output of the add to the density. So here you can play with some settings with the noise here, but in my case I will keep it to permanent noise, and I will decrease the frequency to 0.6, and I will change the offset to 2, and I will increase the roughness to 1. So now I can add a second noise, so I can copy and paste this volume warp with Alt and left click. So let's plug the output of this first volume warp to the input of this second volume warp. So now we can dive into this one and we can change some settings for the curl noise. So here for this one, I will change the noise type from purely noise to simplex noise. And here I will increase the frequency to something like 1.5, and I will change the offset and put it to 2.1. And here I will decrease the roughness to 0.75, and I will decrease the amplitude to 0.5. So now we can convert this density VDB to SDF. So to do that, let's use the convert VDB node. And here we can convert to VDB, and we can convert it from fog to SDF. So now you can convert this SDF to polygon. So let's add the convert VDB node. And here with the convert VDB node, you can convert it to polygon. And here I've made a little mistake for my two volume warp. So you can dive into the first one, and here you can plug the density value here on the first input of the add, and you can do the same on the second one. You can plug the density and put it here, and now you have this result. So now let's use a node called labs delete small part to remove all those tiny pieces here. So to do that, you can add a node called labs delete small parts, and here you can simply select the option called extract largest pieces. So in that case, it will remove everything except the biggest pieces of the scenes. So now we can smooth this geometry a bit. So to do that, we can use VDB one more time. So let's use the VDB from polygons. And here we can put the voxel size to 0.01 to keep all the details. Now let's use the VDB smooth SDF. And here you can put that to Gaussians. And you can put the iteration to 6. And now let's convert that back to polygon with the convert VDB node one more time. And you can change it to polygon. So now let's add some noise, but this time with a mountain sub node. And here with the first one, you can change the amplitude and put it to 0.05. Here you can keep it on 0 centered. And here for the noise pattern, you can keep it on simplex, but you can decrease the element size to 0.5. And now you can add a second one, but this time to add some tiny details on the rocks. So here for the second attribute noise, you can change the amplitude and put it at a very low value, like 0.025. And here you can change the element size and put it to 0.1. So now let's add some normals on the points, like before. So let's add a normal sub node, and you can put the normals on points. So now let's add a scatter node here on the right. And with the scatter node, in my case, I will put the value at 50, but you can change this value at any time if you want. And I will put the global seed at 18. So here I have my points. I will add a peak node. And here for the peak node, I will add a negative value. So I will put the value at minus 0.1. So this is before and this is after. So we can push the point a bit inwards on the rocks. Now let's add an attribute randomize. And here we can randomize our orient attribute. So let's replace the attribute name from CD to orient. And here you can put the dimension to 4. And now let's do the same, but this time for the p-scale attribute. So let's add a new attribute randomize. And we can randomize our p-scale attribute.
Imagine having access to over 40 hours of exclusive Houdini tutorials. And that library keeps growing every month with brand new content. On Artilabs, you'll find in-depth Houdini tutorials covering motion design, simulations, product visualization, and more. Plus, you get access to all project files so you can follow along step by step. And right now, we're offering an extra 20% off the annual membership, on top of the 10% discount already included when compared to the monthly plan. This exclusive deal is available for the first 30 people, so don't miss out. Click the link below, your 20% discount is applied automatically. Secure your spot before it's gone.
So you can replace the color attribute with the p-scale attribute. And here you can put the dimension to 1. And you can put that to custom ramp. In that case, you can have a bit more control over the distributions of the random value. So here you can put the minimum value at something like 0.5 and the maximum value to 1.5. So now you can define the ramp to maybe something like this, and you can make it linear. So now let's add a copy to point. You can plug the points on the second input of the copy to points. And on the first input, you can add a geometry. So you can add a platonic node. So in that case, you can choose between different geometry. In my case, I will put maybe this one. So you can see the result of the geometry, but you can change it at any time if you want to get different results. So here for the radius of the geometry, I will decrease it to 0.29. Now let's add a normal node. So here let's create a loop. Let's add a loop for each connected pieces. So here let's add a scatter node. So you can plug the loop here on the input of the scatter node. So in my case, I will put the total count to 1. And here you can play with the seed if you want, but in my case, I will keep it at 0. So like before, let's add an attribute randomize. And we can randomize our p-scale attribute. So we can replace the color attribute with the p-scale attribute. And here you can put that to 1. And for the minimum value, I will put the value at 0.7. And for the maximum value, I will put the value at 1.4. So now let's add a second one, attribute randomize. But this time we want to add randomize for our orient attribute like we did before. So we can replace the color attribute with our orient attribute, and you can put that to 4 as this is quaternions. Now let's add a copy to points and plug that to the second input. And in the first input, I will add a new platonic. So in that case, I can change between different geometry. So you can plug that to the first input. And here for the settings of this one, I will maybe choose this geometry, and I will put the radius to 0.35. So now let's add a boolean. You can plug the loop into the first input, and you can plug those geometry here to the second input of the boolean. So here you can keep everything by default on the boolean node. So now let's add a new node, labs delete small part. And here for this one, I will put the threshold value at something like 0.4. Of course, it depends on your small pieces that you have here on the scenes. Now let's convert that back to VDB. So let's use the VDB from Polygon. And here for this one, I will decrease the voxel size to something like 0.005. Now let's add a VDB smooth SDF. And here you can put that to mean curvature flow. You can put that to maybe 8. Now let's convert that to Polygon with the convert VDB node. And here you can put that to Polygon. So now let's add a new VDB smooth SDF. This time you can keep it on mean value, and you can put the iteration to 1. So now let's take our main rocks just after the normal node here, before the loop. And let's convert that back to VDB with VDB from polygon. And here with the VDB from polygon, you can decrease the voxel size to the same value as we used before. So this is 0.005 in my case. And now let's combine these two with the VDB combine node. So you can plug that to the first input, and you can plug this one to the second input of the VDB combine. And here you can change the operations and make it to SDF union. So now let's use the VDB reshape SDF. And you can keep the operation to delete, and you can keep the value at 1. So now let's use the VDB smooth SDF. And here for this one, you can keep it by default, which is min value, and maybe you can decrease the iteration just a bit to maybe 2. And now you can convert this VDB to polygon with a convert VDB node. And here you can put that to polygon. So now let's add an attribute wrangle. And let's set an attribute called mask, and let's put the value at 0 for this part of the geo. So f at mask is equal to 0. Now you can copy and paste this one. And here you can convert those part of the geo back to polygon with a convert VDB node. And here you can put that to polygon. So we have the result with only this part of the geo. So you can put that to the attribute wrangles, and here you can put the value of the mask attribute to 1. And now let's add an attribute transfer. So you can plug that to the first input and plug that to the second input of the attribute transfer. So now we can check the results of the mask by clicking on the little information tab of the node. And now you can enable the mask attribute. So here under the point, you can select the mask attribute. So in that case, we can transfer the mask from here to here. And here under the condition tab, you can decrease the distance threshold to something like 0.075. So now you can see we can create a mask attribute based on this part of the geo to the main rocks. And later we can use that for the shading and also for the different attribute noise. So let's add an attribute blur to blur the edges a bit, because you can see for now it's very straight. So here on the attribute blur, you can replace the position attribute with the mask attribute. And here you can maybe increase the value to something like 25. So now let's invert this mask value and create a new attribute based on that. So to do that, let's add an attribute remap node. So we can take our mask as an input. And here we can create a new attribute based on that. And maybe we can rename it something like mask inverted. And here you can just flip this one, and you can see the result of the mask inverted value. And you can see we have reversed our mask. So now we can add a new mountain node. So here with the first one, we can add some large detail. So we can rename it something like large. And here we can multiply this node with an attribute. So we can use our mask inverted attribute for this attribute noise. In that case, we can add a noise only when we have the red part here on the rocks. So here you can use the blend value, and you can use the attribute called mask inverted. So here you can put the amplitude to 0.1, and you can increase the element size to 1.5. So this is before and this is after. If you want, you can play with the offset. Now let's add a new one. You can add a new mountain node. This time we can add some mid detail. So you can rename it mid. And here, like before, we can enable the blend value, and you can use the attribute called mask inverted. So here for this one, we can change the amplitude and put the value to 0.035. And here you can put the element size to 0.5. So this is before and this is after. And now we can add a new one, but this time for the small details. So you can rename it small. And here for this one, we can change the value and put the amplitude to 0.025 and put the element size to 0.1. And now let's add a new one, but this time for the tiny detail. So you can rename it tiny. And here you can change the amplitude, put it to 0.02. And for the element size, you can put it to 0.001. So now we can convert that back to VDB one more time. So we can use the VDB from polygon. And here you can put the value to something quite high res to keep the detail of the rock. So we can put the value at 0.004. And you can use the VDB smooth SDF. So here you can put the operation to min curvature flow. And now let's add a convert VDB node. And here you can put that to polygon. So now we can take our mask attribute back on the rocks, because we have lost it with the VDB from polygons. So we can take this one with the f at mask is equal to 0. And you can put this value here for the main rocks. And now we can take our attribute transfer and attribute blur one more time. So we can copy that. So plug this first attribute transfer here on the first input and plug that to the second input. And now we have our mask back on the geo, so you can see the result of the mask attribute. So we can use this mask for the shading, and if you want, you can play with the value here on the distance threshold. So now let's add the normals, and let's add the null to specify this is the output for the rocks. So you can rename it out rocks. So this is the result for the rocks. Of course, you can play with different settings. You can play with the different points on the scatter node for the first one, and also for the second one, which is here. You can play with the global seed to change the position of the different geo. And here you can switch between different geometry on the platonic subnode. So we have the first one here, and we have the second one here. So you can play with different solid type if you want. And you can play with many different settings just to change the positions, the noise, and so on. So you can play with different settings, and in the next video, we can dive into fluid simulations. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxa.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.